you want to see before we get to the book? These been pretty good for you? Good. If you need help with these, come see me in my office. And then the next thing we did was page 433. 1 through 77 odd, I believe it was. Any questions on those? 61. 61? Okay. Anything else? Okay, there's a few on here that I want to do too. That's just up. And now we're doing number 61. We have 2 points. And we want to find the exponential function c a to the x. Is that what it says? Yes, ca to the x. F of x is going to equal ca to the x. Okay. 61 and 62 are very similar questions. I guess what I have to say here is they give you a great deal of information right here. And let's see if I can put it to you in terms of just English, and then I'll show you the math version of this. If this particular exponential function was, say, a function dealing with time, then this would mean at time 0, there was 3 units of a particular thing that we're interested in there. This right here guarantees you that the number in front of you has to be 3. So I already know that the function looks like this. F of x equals 3a to the x. However, that's just intuitively. Let's look at it from a mathematical perspective. This is the value x. This is the value f of x. And if it has to be of the form like this, fill in the dots. You have f of x equals to c times a to the x. Put in the 3 must therefore be c times a to the 0. Right? There's your x, that's a 0. Here's your f of x, that's 3. Well, why? What is anything raised to the 0? 1. Except 0, of course, right? But we said before that a, all the bases of these exponentials, has to be greater than 0, strictly greater than 0. So we can never have to worry about raising 0 to a 0 power, or for that matter, 0 raised to a bunch of powers would just be a straight line anyways. And we also said a cannot be 1. So going back to here, this guarantees this goes to 1, so c must be what? 3. That's the mathematical way of saying what I just said before. At the initial value of this exponential function will always be 3 that goes out in front. So I'm here. I still don't know what a is though. What is a? Well, this one will help you get the c value. This one will help you get the a value. How can I get the a value from here? Well, do the same thing. We now know that f of x is equal to 3a to the x. Here's an x. Here's an f of x. That means that 12 is equal to 3a to the second power. Because there's your x is 2, and your y is 12, or your f of x. The f of x and y is the same thing. How does that help? Well, divide both sides by 3, and you get 4 is equal to a squared. So what does a equal here from this equation? It actually equals plus and minus 2. Don't forget the plus and minus deal when you take the square root. However, I again refer you to our restrictions for a. Can a be negative 2? So I have dealt with the negative version. I said I don't use it. So a must be 2. So that means my equation is f of x equals 3 times 2 to the x. That's an exponential that both of these equations, both of those points work for. Does that make sense? From the looks of you guys, I can see everybody did this problem. And only one person asked one question with his homework. That's good. All right. Now, I'm going to go ahead and show you a couple ones that you probably should have asked me, but let's see. to take a look at number, well, this is the same thing, so let's just continue with it. Number 57. This is one you were assigned, and it says the same thing. We're finding that f of x equals strictly a to the x, and I give you the point 3 and 216. How do you find the a value?
You find the base of what raised to the third power is 216?
That's the intuitive way to do it. Yes, that's how I would do it. But strictly speaking, we actually have pieces to plug in. This is f, and this is f of x. Right? X and y, f of x and y are the same thing. So that means this number goes here, this number goes in for x. So 216 is equal to a to the third power. And then you write this exponential equation the way you did the exponential equations on the worksheet, and say this is 6 to the third power is equal to a to the third power. So what is a equal to? A must therefore be 6. All right. Is there anything else on this particular page that you guys want to see? I want to investigate this equation right here a little bit. 6 to the third power equals a to the third power. I think that it's clear here that a must be 6, but we originally started with 216 is equal to a to the third power. And we turned 216 into 6 raised to a number because, well, we've seen that number a few times actually in this class on Tuesday. But in general, I would not have expected you to walk into this room last week and say, 216, oh sure, that's 6 cubed, I know that. Generally speaking, you don't have your cubes mastered. Some of you do, but not always. Another way to handle this equation, instead of turning this into a 6 cubed, would be to raise both sides of the equation here to a particular value. And that's the question I have for you. What is the particular value that you would raise it to? Yes. Somebody want to explain it? Somebody else want to explain why 1/3 is a good option here? Well, if you raise this to the 1/3 and this to the 1/3, I guess I have to stop you. Am I allowed to raise an equation to 1/3 on both sides? Sure. What good does it do on this side over here? This is going to be a to the 3 times 1/3, which is just simply a. And this becomes the cube root of 216, which we then found out in the calculator to be 6 equals a. There's a little bit of a different way to look at the equation. Raising it on both sides to the power that will get you back to your exponent is not a bad way to go. Of course, we could also do it this way. Yes?
Say it's a square, would you be like plus or minus 6?
You would? Yes. If it was a square, you'd be plus or minus 6. Good question. Except for, and I erased it, a can't be negative. So we would say a would be plus or minus 6 according to the equation. But then we're going to ignore the 6 because we can't have, the negative 6 because we can't have negatives. But yes, that would be very, very good observation. It leads me into something that we're going to start working on today. This equation right here. 217 is equal to a to the 3rd power. Okay, we know that 216 is a cubed, but what if we had 217 was equal to a to the 3rd power? Well, one idea would be to raise both sides to the 1/3 to find out that a is, well, the cube root of 217, which isn't anything nice, right? That's one way to do that. But there's also another way to do that, and that's to use something called a logarithm. You guys familiar with logarithms?
I've been told that we're going to have to do it.
You've been told that. Okay. Well, yes, that's what we're going to start working on today. So the book has a definition of logarithms. I have a worksheet that I want to put out for you guys, but if you would please turn to page 452. I'm going to write the definition of logarithms the way I learned it. It's the same as the book, just that they just do it backwards, and I'll show you why I do it the way I do it. Okay. The definition of a logarithm. Log